There are four basic forces which act on an aeroplane in flight. The lift of the wings has to counteract the effect of gravity on an aeroplane's mass. This is called weight. The engine must push, or in the case of a propeller-driven aircraft, pull the aeroplane forwards with enough thrust to overcome the drag of the air. All four forces act in different directions during straight and level flight. Lift will be vertically upwards, weight vertically downwards, thrust horizontally forwards, and drag horizontally backwards. For stable, steady flight, all four forces, lift, weight, drag, and thrust, must pass through the same point and bring about equilibrium. The aeroplane experiences the least drag when it flies with the best lift-drag ratio. We talked earlier about the density or thickness of the air being important. Lift and drag, two of our four basic forces, depend upon the density or thickness of the air. The denser the air, the greater the force it produces. When a body is pushed or pulled through the air, it causes a disturbance in the air from which it experiences a force. The amount of that force depends upon the shape of the body, on its speed through the air, its size, and on the density of the air through which it passes. We have agreed that all four forces must be in a state of equilibrium. They must be balanced if we are to maintain a condition of steady flight. If lift and weight are equal, a constant height can be maintained. If thrust and drag are also equal, a constant speed can be maintained. If, however, the lift is far back and the weight forward, the aeroplane will tend to turn on its nose and is said to be nose heavy. This condition also applies if the thrust is high and the drag low. The reverse is also true, in which case we are said to be tail heavy. An aircraft may be loaded so as to be nose or tail heavy due to the positioning within the aeroplane of freight, passengers, fuel, etc., yet still be within operating limits. Also, as the aeroplane burns off fuel in flight, there could be a change in the balance, although this can be partly corrected by moving fuel from one tank to another. The function of the tailplane is to help balance these residual moments. We are all familiar with the engine of a car, even if we leave it to somebody else to maintain. As professional aircrew, we should also be familiar with the fundamentals of an aeroplane engine, particularly as it relates to thrust, one of the four basic forces. Whether you crew on a propeller-driven aircraft or a jet, the force provided by the engine depends upon the principles of pushing air backwards with the object of causing a reaction or thrust in a forward direction. Let's look at the three most common forms of propulsion used within the airline industry, although the first is no longer in common use, that of the piston-driven aircraft. In effect, the engine works on the same principle as that which powers your car. It simply drives a propeller instead of wheels. This is yesterday's technology, and few piston-driven large commercial aircraft continue in service, although it remains a common form of propulsion within the general aviation industry. More common is the turboprop, which is simply a jet engine where the principles of propeller and jet propulsion are combined. Then we have the basic jet engine. How does a jet engine work? Air passes through a compressor, which pumps it at pressure into combustion chambers, where it mixes with vaporized fuel and is ignited. This produces hot gases which, still at high pressure, are passed through the turbine blades and turn them into sufficient force to turn the compressor. The remaining gases shoot out at high speed through the exhaust nozzle. The explosively expanding gases inside the engine push in all directions, but are only free to escape through the nozzle at the back, and it is this reaction against the escaping force that propels the aircraft forward. The advantages of a jet engine over a piston engine are that, kilo for kilo of weight, they provide more power and are more economical. Also, having fewer working parts, they are easier and more economical to maintain, as well as being more reliable.